We're at Greenbelt Honey today, and we're showing a Sunpillar's Hive Health system built by students from Sheridan and Humber and University of Waterloo, and actually Seneca was involved as well with some predictive analytics used here. The heart of the system is a printed circuit card, which is really a sensor board that contains an SD card, smart digital card, to capture data locally. So you take that out, put it in your computer, and then see with a timestamp what the recurring sensors have been picking up. The real-time clock is on the board. In addition, the sensors include a sound sensor at the top and a temperature sensor which goes into the hive. Temperature changes can actually predict swarming, and temperature changes are important. We also have a ventilation fan because above 35 degrees we have issues with the queen laying. To read the data locally, we have a Bluetooth application that sits on an Android tablet. So within 40 feet of the Hive Health system, you can pick up the data. And with this particular unit that we have, there's a technology called LoRa, L-O-R-A, which is low power, long range. Less power than a cell phone, but more power than Bluetooth. So in a rural environment like we have here at Greenbelt Honey, it's a 14-click to the nearest gateway or hotspot in order then to get on the internet and pick up the data. The assembly here is a one-stop shop for beekeepers. For $8.99, we wish to move this with a nucleus, so there'd be bees in here, for example. There would be at least the two supers, which would hold the nucleus of bees. And then we'll open this up in a second, but we'll show you a weight sensor so you can monitor the accumulation of honey. At some point in time, you tend to take the honey supers off once they get full, otherwise you have a honey-bound situation with hives. We also have a CO2 sensor, bees breathe, and the higher the CO2 level, the busier the hive. We're really trying to monitor the health of the hive with external environmental parameters measured in to see if we can do some predictive analytics with our hives. In the top cover here, which is a molded top cover, in order to keep a battery alive, we have solar panels charging it. As you can see, there are 10 of them. This is a lithium polymer battery. This powers the electronics, the ventilation fan, the temperature sensor inside. This happens to be an antenna style, not necessarily the one that we will use, but in order to connect the sensor data to the internet via the LoRa technology, this is one style of antenna that's essentially shield mounted. And the life of the battery is around 2.5 weeks without solar coverage, without sun. For example, you could say in the winter, but bees, because they are essentially nuked up and tight in the winter, there's really not a need to keep the monitoring going on. Unless you really want to, and then we can limit the data that's pulled and try and extend the life of the battery. In addition to a full unit, we have rain gauge, anemometer, which gives you wind speed and wind direction. So again, if you can't measure it, you can't manage it. And the attempt here is to pull in as many variables as possible. So along with barometric pressure, humidity, and temperature in the top cover, and luminosity, so you have the light intensity, we now have a full-up Hive Health system. If I start to take this apart and show you what's inside, we can see, for example, this is a temperature sensor which would fit into the hive, into the bottom of the hive, and monitor what's going on in there. And what we're going to do is we're going to take this hive apart. And this is a classic beehive bottom board. In this case here, we happen to drill a hole in it for the CO2 sensor. This panel here is used to measure the weight of the hive as it accumulates. These are 4 load cells. So we're good for 200 kilograms. Each are 50 kilogram load cells. And here we have a carbon dioxide sensor. When we bring the cables up to the top electronics, we can also measure the carbon dioxide activity in the hive. With 2,000 parts per million activity, you know you have a very busy hive. With 400 parts per million, which is ambient air, you know your hive is dead. Between those numbers, you can have an indicator as to the health of the hive. In addition to a sound sensor and a temperature sensor, you have a lot of input as to what's happening inside of the hive. As far as the electronics go, that is the electronics proper. The electronics as a standalone is approximately $300 and some, let's say $390, and therefore a full unit would be an $899 package with bees, supers, with a subscription for services including training.